Good afternoon, dear students. Welcome to another class on Introduction to Data Structures and Algorithms. In Module 3, today we are going to discuss about stacks and its operations. In the previous chapter, we learned how arrays are used for implementing linear data structures. Arrays provide flexibility in adding or removing elements anywhere in the list, but there are certain linear data structures that permit the insertion and deletion of operation only at the beginning or at the end of the list, but not in between, that is in middle. Such data structures have significant importance in system processes such as compilation and program control. So, stack is one of the important data structure, which is in fact one of the very first data structures that students get familiar while studying this particular subject. Let us see what is a stack now. So, stack, what is a stack? Stack is a linear data structure in which items are inserted and removed only at one end, which is monitored by a special pointer, a special variable, you call it as top of the stack. Thus, there is no way to add or delete an element anywhere else in between the stack elements. So, stack is based on a principle called LIFO, last in, first out. That means the data or the element that is inserted into the stack is the first one that is to be removed from the stack. Let me give you two examples. Suppose in a box you are placing all the books. The book you place first will be kept at the bottom, and next it will be placed on the above, on the above, on the above, on the above. So you'll be keep placing the books one above the other. The last book that you place in the box will be on top of it. Whenever you open the box and try to remove the books, you try to remove the first book that you have placed last. So that is one example. Second example, you might have gone to various parties, marriage receptions. During your buffet, they might have kept the stack of plates. So, always the plate on the top you will be taking it, but that is the plate that is placed at last. So, only one end is used to take out the plate. Similarly, another example of a stack is a set of bangles owned by your mother or sister into their arms. The bangle can only be worn from one side of your hand and removed from only one side. Okay, and middle bangle you cannot remove it. Okay, and of course that is one very good example of the stack. The bangle which you have your mother has worn last, that can be removed first, right? So that is one very good example of stack. And of course the concept of stack in data structure follows the same analogy as the stack of books or stack of plates We may use stack in data structure to store built-in or user-defined data elements depending on our program requirements. And of course, in many interviews, probably they'll question who discovered stack. Stack was discovered way back in 1957 by German computer scientist Friedrich L. Bohr. While doing a design for a program, so he has developed this. And of course, the next very interesting concept is how stacks are represented in the memory. So that is very, very important approach. You can see, just like the real example counterparts that we have discussed, stack appears as a group of elements stored at continuous locations in the memory. You observe? So it is available continuously in the memory. And of course, each successive insert or delete operation into stack can be done at only one end. That is, the top location of the stack, or the point of addition or deletion, is maintained by a special variable called a top or special pointer, that is top. So top is the special pointer and top is the special variable that is maintained. And stack can be implemented in two ways. Using arrays, it can be implemented, and of course it can be implemented using the linked list also. It can be implemented using linked list also. But when you use linked list, you make use of top pointer. When you use arrays, you make use of top variable. Okay. Next thing is the logical representation of stack, showing the elements at continuous memory location, might be true in case of array implementation, but in case of linked list implementation, this is not true, because the nodes can be allocated at different places, but they have internally links. So that is the point that you should understand with respect to the stack representation in memory. Many times they ask a question in interviews: what is the difference between a stack and an array? Remember, the first point with respect to arrays, an array is a collection of related data values called elements, each identified by an index number. Okay, index number is the number that is used to identify the array. Stack is a linear data structure that is represented by a sequential collection of elements in a fixed order. So of course there is an order which is fixed. And second point with respect to arrays is that the objects are arranged in a way such that they can be accessed anytime in a random fashion. Very, very important. Randomly. Array of 0 you can access, array of 10 you can access directly. There is no restriction. But the objects are arranged in a way that they can be added or removed only at one end, and they have to be accessed from only one end. there is a sequential access with respect to stack. You cannot access randomly. So only from one end you can access. That's it. The third point is that arrays, even though it is a random access operation and everything gets down to the beginning of the array, insertion and deletion takes place at any position. But in a stack, the elements can be added or removed in LIFO order, last in first out order, meaning that last one in is the first to be accessed, or first one can be accessed at the last. So there is an order, same order only, it has to be gone, and the insertion in between, it is not possible. The fourth point says arrays supports many operations such as insertion, deletion, traversal, sorting, searching, merging, etc. But stack supports push operation, pop operation. That's it. Only two operators, or only two operations you can do. And stack can be implemented on various data types, but arrays can be on the same data type. So those are the things that you should understand between the differences between stacks and arrays. Now, further, when we look into the stack operations, there are two key operations associated with stack data structure. One is push and pop. Adding an element to the stack is referred as push, while reading or deleting an element from the stack is referred as pop. So that you have to understand. So remember, whenever you are pushing an element, so what happens? The stack top increases its position value and the element is pushed. Same way, when you are removing, whenever you are popping out the element, the stack top reduces by 1, and of course it is removed. Here, two conditions you have to observe. When the elements are full in the stack, that means the capacity of the stack is completely utilized by elements, and if you are trying to push an element, so error occurs. This this condition, you call it as overflow condition. This condition you call it as overflow condition. So overflow condition happens when all the positions in the stack are completely occupied and it is full, and still you are trying to push an element, then error condition happens, that is overflow. But this overflow condition is only for arrays. If you implement a stack with linked list, this overflow condition will not be there, because dynamically memory is allocated. There is no question of overflow. But remember, you have popped all the elements. Now the stack is completely empty. When the stack is completely empty and you still do a pop operation for this empty stack, so then another error condition occurs, that is, you call it as underflow condition. Underflow means there are no elements, but still you are trying to do a pop operation. So that is underflow condition occurs. So beyond the syllabus, let us mind jog. Which programming language provides built-in support for stack? Lisp and Python are the two programming languages that provides support for built-in support for stack. So before we end, let us do a checkpoint. What is push operation? Push operation is nothing but adding an element. What is pop operation? Deleting an element. And of course, remember, whenever a stack is empty and if you are performing a pop operation, in such condition, what happens? Stack underflow condition occurs. This is an error. It is always advisable to implement appropriate underflow handling condition check while writing the program. So, in the next class, we'll be discussing about stack implementation using arrays. That's all for today's class. Thank you. Have a wonderful day. All class recordings are available in this particular website.